Hi guys, this is Unit 7, Lesson 3. Today we're going to be talking about factoring polynomials. And today we're really just going to focus on the greatest common factor. There's several different ways to factor polynomials. But overall, factoring polynomials is going to be vital to the rest of the year. And when you get to geometry and algebra 2, factoring is a huge part of math. So we really need to get it down. So here are some different meanings of factor. The first one's a verb. When we say to factor something, it's to write an algebraic expression in equivalent products. So I can give you a really quick example. If I said 10, that's an expression, I could rewrite this as 2 times 5. So that is, I rewrote it as equivalent product. And then the second part is when we say a factor. So this is 2 factor, this is a factor. It's just one part of the factor. So 2 is a factor and 10 is a factor. That's it. All right, so for part 1 here, we have this algebraic expression right here, polynomial, and we want to write each individual term, the 6x squared and the 15x, as completely factored expressions, and then we're going to determine the greatest common factor. We call this the GCF. So I'll give you the first part. So if we want to break this down, we want to know everything that we can multiply to make this. So it'd be something like this, 3 times 2 times x times x. So that has completely factored this expression. I can't break 3 down or 2 down. I don't want to say 1 times 2. We never use 1 as a factor because it goes into everything. So you guys quickly see if you can do this 15x. So hit pause and write down the factors of 15x. Okay, did you write something like this? 3 times 5 times x. Okay, now we need to find the greatest common factor between the two terms. So what you do is you look for common factors. 3 and 3 are both common factors, and an x is a common factor. So if we combine those, we would get the greatest common factor, and we write it like this, GCF equals 3x. There we go. So that's what's meant to find the GCF. Then we're going to use the kind of reverse of the distributive property, and we want to rewrite this, and this is called factoring by GCF. So get this down. So if it says factor, we always look for the greatest common factor. We're going to change this into something that's a product, and I'll show you. So the way I always do it is once you find the GCF, I divide each part by the GCF. And this one's going to be easy, but it's going to get harder. So if you learn this method, it'll make it easy. So I took each of these terms, divided it by the GCF, and that's pretty easy. We know how to divide these. I would get something like this, right? 6 divided by 3 is 2. X squared divided by x is x. Over here, 15 divided by 3 is 5, and x divided by x would cancel out. Now what we need to do is once you do the division, then you're going to place the GCF out front. And the reason you do that is because you could see that if I were to multiply this, I would get back to our original polynomial. So this is its factored form, just like I told you that 2 times 5 were the factors of 10. This thing times this thing equals that polynomial. So this is what we mean by factored. And you can see it's the greatest common factor because if I look inside here, I can't split this up into any more common things. Nothing goes into 2x and 5. Okay? So we keep practicing, and hopefully you'll get this down by the end of the lesson. All right, so this one pretty easy. What they want you to do is evaluate both this term and the one the answer. So this term right here, this guy. So evaluate both of those, 2 separate things, if x equals 2. So plug 2 into both, see what do you find, and does it support about the 2 expressions. Okay, so go ahead and do that, hit pause and try it now. All right, so when you did this first expression up here, you should have did something like that. You plugged in 2, just did some math, evaluated, and got 54. Then we're going to put our answer for part B, which was this one here, so this factored form right there. When you put in the 2, you still get the same answer. So it's just showing you that both of these expressions are equivalent. And you can write something like this. You find the 2 expressions have the same value, x equals 2. This supports the fact that the 2 expressions are equivalent, have the same values for any given replacement value. All right, if you need to, hit pause and fill that stuff in. All right, so like we said, it's very important to become fluent in factoring. So for this first, or exercise 2, basically all we want you to do is just find the greatest common factor. You don't have to completely factor it, just what is the greatest common factor between all these terms. So I want you to do all these before you hit play. So hit pause, see if you can find the GCF of all these parts. Do that now, please. All right, how'd you do? For part A, hopefully you got something like this. Now, you don't have to show all the work that are in these notes, but this is just a really easy way of always finding it. So you break down 12, you could do something like 6 times 2, but then I have to factor completely, and 6 is 2 times 3 times 2. So that's where they're coming up with these right here. Okay? And then the x's are really easy, you just break them down. Now you're looking for common ones. So this one has a 2. Whoops, let's get a pin here. So we have a 2, a 2, and a 2, that's common. 1, 3, 1, 3, 1, 3. So that has to be completely common. And 1x, 1x, 1x. I can't say 2 x's because this guy doesn't have 2 x's. I can't say 2 3's because this one doesn't have 2 3's. So what's common is the 2, the 3, and the x. And when you multiply that, you get the 6x. And that's how you do GCF. So I won't explain all the rest. Just look at the answers, see if it supports your work, and hopefully you'll start understanding how to do these. So here's your GCF here. Part C, hopefully you got 7x to the y to the 5th. So when I do variables, it's really easy. I just look at the two variables and I see what's the smallest amount. So there's 1x here, there's 2 x's there, so they both share at least 1x. For the y's, there's 5 here and 7 there, so they both share at least 5. So that's how I do my variables pretty quick. Okay, keep moving on. Over here, just to 8x, you can see the smallest amount of x's is 1. So that's the common x. And then just what number goes into all these. You'll catch on pretty quick. I take the smallest number and see if it goes in the rest. So 8 goes into these. Obviously, it can't be bigger than 8 because it needs to go into 8. Okay, and then we move on to this one here, and you get 4x. And finally, f, 9xy. So remember the smallest amount of the letters. There's 1 x there, there's 1 y there. You can't say more than 1 x because this term doesn't have more than 1 x. This term doesn't have more than 1 y. All right, hopefully that went okay because you really need to know how to find GCF for the next part. All right, for exercise 3, what we want you to do is now completely factor the expression. So you're going to find that greatest common factor. You're going to divide everything out, and basically what we want you to do is write it like we did this term right here. Sorry. Okay, let's try this again. This is what I was trying to do. This term right here, this is completely factored. So once you have that GCF, you're going to divide the terms. Make sure you put that GCF out in front like we did there, and you're going to completely factor it. So let's jump back over here. Okay, so you do all these parts. There's quite a few. Only hit play. Now, if you want to maybe watch 1 or 2 and then try the rest, but make sure you're trying most of these on your own. So hit pause now, please. All right, let's see how you did on part A. So you should have identified the GCF as 2x, and then pretty simple, if you divide this by 2x, you would end up with 3x. You divide this by 2x, you'd end up with 5. And you could always check your answer, guys, really easy by simply just distributing this. See what happens. What's 2x times 3x? Well, that would be 6x squared. What's 2x times 5? That would be 10x. So if you redistribute this and you get back to this polynomial, then you know you are correct. So if you want to hit pause and double check those, you can, but see if you can do it on your own. It's very important. Question B, hopefully you got that. As you can see, there's not an x in common, so they don't have to always have a letter in the GCF. It could just be a number. Sometimes it could just be a letter. All right, so there's that one. Part D, there's that. And part E. Part F, and the last couple here. Too bad you didn't make one where just a letter was common, but that's okay. All right, so that is GCF factoring completely, so you really want to get this down. All right, these next questions A little tricky, but probably something good to have. You'll see this later on when we start completing squares and doing some fancy stuff. So before we do this one in factor, I'm going to bring up this little example and it's going to help things out. So let's take a look at this right here. So hopefully you can follow me. 16, I could split into 6 plus 10. We know that. And now I could factor 6 into 2 times 3 and 2 times 5. So this expression is similar to this expression here. Hopefully you can see that, where we're doing this times this plus this times this. Now hopefully you see that 2 is a common factor between those sums. So 2 is the GCF of this expression here. So therefore I could take the 2's out, and when I do, I bring it out front, and I'm left with the 3 plus 5. Then I could add 3 and 5 and get 8, and we know that 2 times 8 gets back to that 16. Well, they're going to do pretty much the exact same thing as this one, but just with this big polynomial. So hopefully you see that in this polynomial, that the x plus 5 and x plus 5 is being multiplied by both these terms, so it is a common factor of this big expression. So, if I can slide this, there you go. So the GCF is x plus 5. So just like before, I can divide this out, take this part out, and what's left with is these two terms, and I would put the GCF out in front. So again, here's that x plus 5, and what's left is these two guys in the middle here. Then just like we added the 3 and the 5, we can add these together. There's a little extra step in here that we probably wouldn't do ourselves. They're doing the different associative properties and commutative properties. It just took away the parentheses and moved things around. And then you could see that if I added the x and the 2x, I'd get 3x, the -1 and the -3, I'd get -4. And this now is factored completely, and it's nice and simplified. So this is another good skill we could do. So why don't you try to do the same thing on B here. So use this scale here, or use this example, and if you want to, use all these to help you out too. So hit pause and see if you could do B the same way we did A. Okay, how'd you do? So here's the answer. Hopefully you ended up something like this. Take a look at the work and the GCF and see if that makes sense. And we'll give some of this practice in class. See you in class.